Welcome to Study Loop.
Hi. So, in this question, we are given a wire that is suspended from 2 points, and we are given that the length of this wire, like the complete length, is s equal to 76 meters, and the horizontal distance between these 2 points from which it is suspended, this is given to be 75 meters. And it is also given that the mass per unit length of the cable is 2.2 kilogram per meters. So we have to find the sag of the wire, the distance from the lowest point in the wire to this horizontal line. So we have to find this h, the sag. And so in the part A we will find the sag of the wire, and in part B we will look into finding the maximum tension in the wire. So this is the problem statement. So we know that if we take this point as the origin, the lowest point in the cable, and make a xy coordinate axis right here, a rectangular coordinate axis, then at any part of this cable we can find the length of the cable from this origin to that part. So we will take this as the point, the second conductor, and we will find this length. Let this length be equal to S1, and we can see from the symmetry that this S1 would be equal to half of the S, and S is given to be 76 meters. So we will use this equations for this S1 to get H, because H, or the sag, because the sag will be a part of that equation. Okay, so let me write it here. So So according to the equation, this S1 is equal to x. There is a distance from the lowest point, the origin, to this point at which we are considering x. X here is 75 divided by 2. So 75 is the complete length, and y is just h, because this is the elevation of this point above the origin. So S1 is equal to x into 1 plus 2 over 3 times x over y whole square. We are given that we have to use only two terms of this formula, two terms of this equation, because beyond two terms the third term will have a very less value, so it will not matter. We just need two terms, and let us substitute the values of x and y at one of these at this point into the equation. So x is 75 divided by 2, 1 plus 2 over 3. This is again 75 divided by 2, and y is, sorry, this formula is not x over y, this is y over x. It's my mistake. So this is y over x. We have to make the correction here also. So y at the point we are considering is h, and x is 75 over 2, 2h over 75, and its whole square. Okay, and S1 we know half of the half of the complete length. Like S1 is 76 over 2 because 76 is as the complete length of the cable. So it is 76 over 2 is equal to 75 over 2 into 1 plus 2 over 3 times, if we make the square, this is 4h square over 75 square. Now solving for h, we can find the sag. Let us solve for h. So 2 is cancelled here. So it is 76 is equal to 75 plus 2 over 3 into 75 into 4h square divided by 75 into 75. So this gets cancelled here. And this is simply 1 times 3 over 2 is equal to 4 h square over 75, and from this h square is simply 75 into 3 over 8, and it's h square is this, it's right here. So h is now under root of 75 into 3 over 8, and this h or the sag comes to be equal to 5.303 meters. So this is the solution of the first part of this problem. H equal to 5.303 meters. So in the second part we need the, also part B here, we need the maximum tension. We know maximum tension in the cable is the tension here, tension all along the cable, and which is the resultant of the horizontal tension. There is a tension at the lowest point. Tmax is the resultant of horizontal tension, and the tension in the vertical direction due to the weight. Okay. Let me remove this. Okay. So we know that we are given the mass per unit length as equal to 2.2 kilogram per meter. We can easily convert it to weight per unit length, that is denoted by small w, and that would be equal to 2.2 times the acceleration due to gravity, 9.81 meter per second square, and this will come to be this much Newton per meter. This times this. So we will use this as it is in the in solving the problem. So we know that the equation of the, because this curve is a because this shape of this cable is a parabola, because the load on is a distributed load. It is hanging two between two points, and its shape is parabolic. So we know that y, or it's because the properties of a parabola, this is a formula, y is equal to w x square divided by 2 t naught. From this we can, this w is the same as this w, and from this we can get the t naught, or the tension at the lowest point on the horizontal tension, is equal to t naught is equal to w x square over 2y, and we can put any value of x and y here. So I'm putting the value at the second point from which is being suspended, from which the cable is being suspended. So for the second point, this point, x is 75 over 2, and and the height, and the y is h, and we already have h from the previous solution to be equal to 5.303. We are running out of space. Let me write it below. I'm writing it here. So T naught is equal to W that we got from here, 2.2 into 9.81 Newton per meter. 2.2 times 9.81 Newton per meter times x square. X was 75. Oh, x at this point was 75 over 2. This is 75 over 2, and it is x square, so 75 over 2 times 75 over 2 divided by 2 times the y at that point is h that we calculated from here, from the first part, that is equal to 5.303 meters. Solving this, we will get the value of the horizontal tension to be equal to 820.116 820.116 newtons. We also need one more tension, the vertical tension, because only through that we will be able to get the resultant tension or the maximum tension in the cable. So I think I made a mistake here. This The solution of this will not be this. Actually, I'd done it in my notebook, but this will be this. This should be 2861.56 Newton, and the vertical tension is just the weight acting on the cable. So that weight, this is capital W. So this is small w times the length. Length here is S1, the half of the length of the cable. So this is W times 75. To the length of the cable is the complete length. So this the actual length of the cable. So this is 76 over 2. So it is W, small w times 38, and small w we know to be equal to 2.2 times 9.81 Newton per meter, and the weight would become equal to 820.116 Newton. So we can, so this T naught is acting in the horizontal direction, W in the vertical direction. The resultant of these will be the maximum tension in the cable. So this maximum tension, the resultant, will be equal to under root of T naught square plus capital W square equal to under root of 2861.56 square plus 820.116 square, and this maximum tension comes to be equal to 2976.76 Newton. This is the second part of our problem. So I think that's it. Thank you for following.